Hello, welcome to the video Handling Device Files. In the previous video we learned how to use systemd containers. In this video we'll learn how to use udev rules and set an SELinux label on a device node. Nowadays device files are managed through a combination of a pseudo file system and a user space device manager called udev. This device manager has been merged in systemd as well, becoming systemudevd. There are projects such as eudev which provide udev functionality without requiring systemd to be installed and enabled on the system. The device manager listens on a kernel socket for kernel events. These events inform the device manager about detected or plugged-in devices or the removal of such devices and allow the device manager to take appropriate action. For udev, these actions are defined in udev rules. Now let's step ahead and see how to use udev rules. The main configuration of udev is handled through udev rules. These rules are one-liners that contain a matching part and an action part. The matching part is made up of validations that are executed against the events that udev receives from the Linux kernel. This is based on key or value pairs that are obtained from the event and include the kernel-provided device name, device subsystem, kernel driver, specific attributes, and environment variables that are active. The Linux kernel will also inform the device manager about the device hierarchy. This allows rules to be defined based on, for instance, the USB controller through which a USB device is plugged in. Hierarchically related information is provided through key or value pairs, whose key is defined in plural form, subsystems instead of subsystem, drivers instead of driver, and so on. For instance, to match a particular USB webcam, the match-related pairs could look like this one. The second part of a udev rule is the action to take. The most common action is to create a symbolic link to the created device file, ensuring that applications can always reach the same device through the same symbolic link, even when the device from the kernel point of view is named differently. The previous example could, for instance, become this. The udev application supports many more actions than just defining symbolic links, of course. It can associate ownership or group membership on the device, controlling who can access the devices. Udev can also set environment variables and be configured to run a command. Udev rules are by default provided through the user's /lib/udev/rules.d location. This is where distributions and applications or drivers will store their default rules. Additional rules or rule overrides can be placed in etc/udev/rules.d. Important to remember is that udev will continue processing rules even when a matching rule is found and executed. This can be changed on a per-rule basis through the options action, like with the syntax on your screen, which informs udev that it can stop processing further rules for this event. One of the actions that udev supports is to assign a particular SELinux context on the device node. This is done through the sec label SELinux action. Note that this action is only applicable to the device node that is created. If the rule also sets a symbolic link, then the symbolic link itself is left untouched and will inherit the default device T context. In this video we saw how to handle device files by using the udev files and setting an SELinux label on a device node. In the next video we'll dive into the dbus communication.